Hi, everyone. Today we're going to be talking about inference for quantitative data, and we're going to be focused on hypothesis test of difference of two means. We're also going to introduce how to do the t-test directly in R, so we avoid some of the previous steps we did before. And we're going to introduce some new ideas about checking for normality and equal variance for using the correct t-test and correct parameters. As usual, content from these slides are coming from the Montana State textbook, Introductory Statistics with R. So let's just take a look at some of the content we previously observed in the previous lecture. So the first is related to the hypothesis of a single mean. And by that, we mean of a single variable. So for example, let's take the example of the data here. This would be testing whether or not the mean of a one single variable, such as perhaps the Amazon price of books, is equal to a certain value. And here we said 35. Well, where did we get this 35? This 35 may be a kind of already established mean or a population mean, a previous population mean that we know that we're comparing against. And this should just be X bar like this. I couldn't get it to the bar to be on top of it. So this is X bar, which is the sample mean. So hypothesis test of a mean is the hypothesis test of a single the mean of a single variable. We also did the hypothesis test of a difference of paired values. So that's the values of the same unit, of the same item. And we established it the same way because what we did was we created a new variable that was the difference of the two values that we're comparing. So in a sense, it's the difference of two values or the difference of two variables. But we then just apply kind of like a one mean test of the new variable that we created. That's the difference between the two. And therefore, the hypothesis test is usually testing whether or not this variable equals zero or not. And what does that mean? Well, if it's zero, that means that there's no difference between them. And if it's different than zero, then that means that the difference is either negative or positive. As usual for these hypothesis tests, we can test whether or not it's different, greater than, or less than. But often we want to just check if it's different than a particular value. And that's also, we call this the two-sided test. And this might be just a one-sided test. And if we are not sure, usually just use the two-sided test. It's a more conservative and it should work. Now, regarding the difference of two means that we're introducing here. So it's similar, but not the same as the test of the mean of paired difference. The textbook also called paired mean difference that I just mentioned. And that's because it is a difference of unpaired means. That's what we are introducing here, unpaired. So it's not of the same units. We will follow the theory-based approach, although there are others too discussed in the book, but we'll follow once again just the theory-based approach of the t distribution. And some notations similar to the previous tests that we did. N1 and N2 are sample size of two independent samples. X bar 1, X bar 2 sample means of two independent samples. S1 and S2 sample standard deviation of two independent samples. Mu1, Mu2 population means of two independent samples, and alpha 1, alpha 2 population standard deviation of two independent populations. So in the test of two means, we carry out a test of two means when we want to compare means of two populations or groups on the same variable, of course. So for example, we may want to compare the attendance level in the store in the morning versus the attendance level in the store at night. So what I'm saying on the same variable is that it's kind of an obvious point, but we cannot compare the attendance level in the morning versus how many people play video games at night. It's just not the same thing. So they have to be on the same variable. That's the only way it makes sense logically. But note that the people that attend in the morning may not be the same people that attend at night. So that's why this is unpaired and not the paired comparison. Or for example, pay levels of women versus men. How many people reading are reading fiction versus how many people are reading nonfiction, and so on ad infinitum. So this is a very useful test, and it can be applied to all sorts of situations in the world. And as we're following the theory-based approach, we're going to use the t-distribution for differencing means. The t-distribution can be used for inference when working with a standardized difference of two means if, once again, independent, we have an independent sample and normality. So the data are independent within and between the two groups. We are focused on comparing two groups or two populations. This is the whole thing about unpaired sample. So the people that you're acquiring data from, or the things that you're acquiring data from, have to be independent, meaning they have to come from a random sample, and you have to make sure there's no bias in that sample. So for example, if you're checking attendance level of people in your store in the morning versus attendance level of people at night, you can focus all your population is attendance level at your store, or just the people that attend your store. But you cannot choose, for example, some tall people in the morning and then choose the short people at night. That is going to screw up your study. So independence means you're getting a random sample of people in the morning and a random sample of people at night. And normality, we check the outliers for each group separately, and we'll also talk about a standard test for normality. So we need to really make sure those two conditions are met, otherwise the study doesn't work. And here we have a calculation for the standard error, which is similar but slightly different than the previous standard error calculations. And this is important because this will go into the equation for the t-score that we need to identify the probability of the values that we are dealing with. So next, we actually go into an example of a sample data of mothers with newborns to illustrate these ideas.